This is our third lesson on solving quadratic equations by using the zero product property. So today we're going to review the AC factoring method and then the difference of squares factoring method, using those in order to solve for answers to quadratic equations. Let's look at the one on the left before I'll let you guys try the one on the right by pausing the video. 2x squared minus 3x minus 35 equals 0. I always, especially when there's a number in front of the x squared, I always want to check and see if there's a greatest common factor. Since I got 2 and negative 3, there's not going to be one here. So that tells me I need to use the AC method. I've got a coefficient, a number in front of the x squared term. So let's just review. AC here, it's going to be 2 times negative 35, negative 70. The B term is just that term in the middle there, negative 3. So I need factors of negative 70 that sum to negative 3. Negative 3 is pretty close to 0. These numbers are going to be pretty close together, with one of them being positive and one of them being negative. I can think of factors of 70 like 10 and 7. Since the negative 3, we have a negative sign, that means that 10 gets the negative. So it's going to be 2x squared minus 10x plus 7x minus 35 equals 0. Before we go on, remember, I'm just changing negative 3x into two terms that sum to negative 3x. Now we got to factor by grouping. 2x squared and negative 10x. I have a common factor there of 2x. Factored out leaves me with 2x factored out is x minus 5. Positive 7x, so I'm going to factor out a positive number. Negative 35, I'm going to take out plus 7. As expected, we get an x minus 5 that matches there. Let's factor this completely. And now I use the zero product property. 2x plus 7 could equal 0. And x minus 5 could equal 0. Solving over here, we would subtract 7 from both sides and divide by 2. One answer is going to be negative 7 halves, add 5. Second answer is positive 5, so two solutions. Okay. Hit pause, try this one on your own. Now hit play, I will do it. GCF, not with 3, 22, and 7. So I got to do AC method. 3 times 7, that's an AC of 21. And it's a B of 22. This one's not too bad because we have all positive signs. The factors of 21 that sum to 22 are 21 and 1. 21x, 1x. And equals 0. Factor by grouping. Can I factor anything out of 1x and positive 7? Technically no, but technically for grouping you have to take out the 1. So I get matching binomials there. Finish factoring. Zero product property. Subtract 1 from both sides, divide by 3. Subtract 7 from both sides. Two negative answers here, right? We started off with all positives, and that means that your answers are ultimately going to be negative based off the nature of that problem. Okay. Those are pretty hard. Those are pretty difficult problems. Let's go down to difference of squares here. A little bit easier. You just have to remember the difference of squares factoring pattern. X squared minus 49 equals 0. X squared minus 49 represents that pattern, a squared minus b squared. That always factors into a plus b times a minus b. So I'm going to factor this left side as x plus 7, x minus 7 equals 0. I'll jump right into zero product property mode. Many of you can probably tell what the answers are going to be at this point. I find it's a good habit to still even write it out. X plus 7 equals 0, x minus 7 equals 0. So I get negative 7 and positive 7. You can leave your answers like this. Another way of writing your final answer here is x equals positive and negative 7. The plus minus sign there tells me that you do have two answers. Okay, hit pause. Try this one on the right if you want. Now hit play. Can I take a GCF out of 4 and negative 9? Again, no. We do want to consider and check if we can do it though. 4x squared and negative 9. These are perfect squares. If I took the square root of 4x squared, that would leave me with 2x. That would be my A term here. We know that taking a square root of 9 leaves me with 3. This factors as 2x plus 3, 2x minus 3 equals 0. Zero product property. Subtract 3 from both sides. Divide by 2. So it's negative 3 halves. I think you can see we'll get a very similar result over here. This time it's positive. So final answer. Let me duck down here. Positive and negative 3 halves. Some somewhat challenging problems based off of using the factoring you learned before the spring break and the zero product property.